exercise 3b. So suppose that the functions, power function on your calculator, this and division, they do not work, and you must calculate an approximate value of 3 divided by 1.2 using the first 3 times in its binomial expansion. So remember, the binomial expansion, in expanding a plus b to the power n, so this is given by a to the power n plus n a to the power n minus 1 times b plus 1 over 2 factorial n into n minus 1 a n minus 2 b squared plus 1 over 3 factorial n minus 1 n minus 2 a n minus 3 b cube, and so on. It continues. But we are interested in using the first 3 terms. Okay, so the first thing to do is to express this 3 over 1.2. We want to express it and take the form a plus b to the power n, because we want to estimate it using binomial expansion. So if we do that, so you're going to say 3 divided by, you're going to ask yourself what makes 1.2. It's 1 plus 0.2. Okay, and now you're going to take it to numerator. Take this to numerator position. You're going to have 3 into 1 plus 0.2 raised to the power minus 1. Okay, so this takes the form a plus b to the power n. So 1 here is our a, and this will be our b, and this will be our n minus 1. The second step, we find the expansion. So just for now, consider this, and you find the expansion for this, and when you're done, you multiply by 3. So let us focus on this for now. So this is estimated to be minus 1. So remember, the first time is just a to the power n. So we said a is 1, so it's going to be 1 raised to the power minus 1, which is just 1. Okay, plus n, it's minus 1, a, it's 1, and we have minus 1 minus 1, which is minus 2, and we have b, which is 0.2. So this is just 1, this is minus 1, so this negative will be multiplied by this positive, giving us negative, and you have 0.2. So you do the same for the third term. So this is t1, first term, second term, and our third term is this. So your third term should give you 0.04. So this is equals to 0.84. But now we are not done. We only considered this expansion. So multiply by 3. This should give you 2.52. So something to note, as you've seen in previous calculations, when taking an estimation, so the exact value is this. So if you use more terms, so here we use just 3 terms, but if you use more terms, you will have come closer to this exact value. So let's look at number 2, in relativistic mechanics, a special theory of relativity, it's a concept in physics. It's a very beautiful concept. So you have actually a special relativity and general relativity. So special relativity, it looks at how objects moved relative to the speed of light. For general relativity, we are looking at objects, how they move relative to each other. So if you have time and you're interested in physics, please look these two theories out. They're very fascinating. You're gonna love them. So the kinetic energy, which we're gonna denote Ke, of an object of mass, we're gonna denote m naught, traveling at a speed, we're gonna denote it v, is given by the expression, which is this, where c is the speed of light in a vacuum. So if this ratio v by c is much less than 1, that is very small, see if you can find the better known classic kinetic energy expression by applying the binomial expansion. Ignore all terms containing powers 4 and higher in your binomial expansion. So the first step, it is to convert this to our form, which is a plus b to the power n. Okay, so that we can expand. So you should find that it's this. Okay, actually you can obtain this from, okay, so you have your radicand. Remember that you can express the square root as this, so it's not a plus, it's a negative. So take this to your numerator, the sign for this will change. So you will have 1 minus v squared over c squared raised to the power minus half. And yeah, you're done. It's in this form. So now we expand. Okay. Oh, before we expand, we choose. Okay, we choose b equals this. Okay, so remember this is our a. Then our b is negative because the original form, it has positive sign. So we have negative negative v squared over c squared, which is our b. Our n is minus a half. Okay, so you should find that your first term is 1. Remember, your first term is given by a to the power n. It's your t1, so your n is minus half. What about your a? Your a is 1, so giving you 1. So your second term is given by na raised to the power n minus 1 times b. So this should give you n is minus a half, a is 1. Okay, we have n, which is minus a half, minus 1 times b, and your b is minus v squared over c squared. Okay, so this will give us 1. So you have minus half times this negative, giving us positive half. And we have v squared divided by c squared. This is our second term. So working out your third term, you're gonna have this. Okay, so the formula, remember it, what kinetic energy m naught c squared, and we take our estimation, we multiply it by this. So if we do that, we're gonna have half m naught v squared. So we have term 1, which is 1. We have term 2, v squared over c squared. This is much more smaller, so we ignore. Okay, so you should find your kinetic energy equals to this.